So in fluid mechanics, unit number 6, dimensional analysis. Okay, this unit will have mathematical technique that we are going to see to solve the numericals. It has some theoretical part in that we are going to use some numbers, dimensionless numbers we call. But first of all, we will need to understand theory. So what is dimensional analysis? Write down the definition. It is mathematical technique dimensional analysis is mathematical technique which makes use of study of dimensions or solving several engineering problems. For example, resistance experienced by car, truck, ship, aeroplane, etc. For example, resistance experienced by car, truck, ship, aeroplane, etc. is function of various parameters. So resistance is what? When the car or truck or aeroplane is flying. Aeroplane is flying in the sky. Car or truck is running on the road. While running, it experiences some drag force. That is a wind force that is offered by the wind on the body of that object. Because of that, its speed is reduced or it takes more power. Okay. So that resistance is a function of some parameters. Which are the parameters? R is a resistance. Here is it later. And it is a function of first of all dimension. Now here we will use letter L for length of that object. If that object is of circular shape, we will use D letter, that is for the diameter. Then velocity of that object. Now when the aeroplane is flying, the velocity of the aeroplane, velocity of speed, velocity of car or truck, that is velocity. That object is running through the air. So parameter or properties of the air will take density of the air, density of the water or the ship. This ship is running floating on the sea water. So their velocity of that ship will be v, and density of that water, sea water, that will be rho. Mu is a viscosity of the fluid. K, thermal conductivity or modulus, Young's modulus, bulk modulus. Okay. So these are some parameters, for example. Now here, this dimensional analysis as a technique, mathematical technique, we are going to use to solve the problem. Which are engineering problems. Now here we will use two terms of this. Here we will get relation between two things. One is a model and another is a prototype. Okay, so prototype is actually machine. Machine means whatever we are going to manufacture, before manufacturing its small version is prepared. Suppose aeroplane is to be tested. Then small copy of the aeroplane, that is called as model, that is manufactured and that is tested for the speed, for the resistance, so many terms. Okay, but its actual size, that product is called as prototype. So prototype is actual machine, and model is what? Replica. So write down definition: actual machine. And this is what? Replica or copy. Replica or prototype. And it is a small scale. This is small scale. It depends on the object. The objects which are big, suppose dam. Dam is a big. So its model will be of small size. But small gear in a watch, this is an analogous watch. In this number of small gears are used. If we want to have study analysis of this gear, then here its replica will be of bigger size, large scale. So it depends on the type of the product. For the watch, that model size will be bigger, and for the aeroplane, for the truck, model size will be small. So that depends on the type. Okay. So these are the two terms. Then here one principle is required, that is called as dimensional homogeneity. What is it? Dimensional homogeneity. Means what? Here any equation if you will take that equation, suppose P is equal to rho GH. This is what? Equation of pressure. Okay, this equation is a equation of pressure. So in this, left side is a pressure and right side either rho GH or WH. Left hand side and right hand side. Its dimensional unit of both sides if are same, then we say that this equation is dimensionally homogeneous. Means we can apply or we can able to use dimensional technique only when the equation is dimensionally homogeneous. Means left hand side and right hand side for their units. Okay, for their dimensional unit, that should be matched. Then it is possible. So for this, for example, how we will see this? See, left hand side. Left hand side, P is a what? Newton per meter square. Unit of this is a Newton per meter square. Right hand side, here, this is what? Product of W and H. So W is what? Newton per meter cube. Into H is the height. Means N. So Newton per meter square is equal to Newton per meter square. Both side dimensions are same. Okay. Now these are shown by Newton per meter square. This is shown by here MLT form. ML minus L raised to minus 2 and T raised to minus 2. Right side ML raised to minus 2, T raised to minus 2. This is what? Dimensional form. This is actual form, unit form, Newton per meter square. And this is MLT form. Now how to write any unit in this form? That will come in further discussion. Currently, these both sides are same. Means this equation is what? Dimensionally homogeneous. Actually, it is a condition. Dimensionally homogeneous equation.